So, in a city of 500,000, there are initially 848 cases of a strain of flu. The CDC in Atlanta claims that the cumulative number of infections will increase by 43% per week if there were no limiting factors. So that would be exponential growth is what they're describing. So let's see, the value of R will be the natural log of 1 plus that percentage rate of 0.43. We want a logistic model of the form n equals k over 1 plus be to the negative rt, which gives the potential cumulative number of cases of flu as a function of weeks from initial outbreak, and determine how long it'll be before 103,200 people are predicted to be infected. Okay. So start with a little sketch. The time is in weeks. Cases on the y-axis. We're looking for a city of 500,000, so the very upper limit of infections should be that 500,000, 500,000 is the upper limit. And so that'll automatically be the value that they're calling k here. So when we go to write our function, we could start with that already, that this should be 500,000. But we don't know what the b value is. We can find the r value though, because they said that r was going to equal a natural log of 1 plus 0.43. So we could plug that in here. Now, start off with 848 cases, and it's going to grow logistically, so it'll approach an asymptote there. They want to know how many weeks will it be until 103,200 cases is reached. So we're trying to find that time t where that occurs. So I would start with the idea that when t is 0, then we have a special situation with the formula where you'd have n equals 500,000 over 1 plus be to the negative r times 0. If the time is 0, anything to the 0 power just becomes 1. So what this creates then is we have n of 0 is going to equal to the initial case count equal to 500,000 over 1 plus b. So that initial case count was 848. So we can now solve for the b value by multiplying this 1 plus b to the other side. So you get 1 plus b times 848 equals 500,000 divided by 848. I get 1 plus b equals 589.623. Subtract 1. So 588.623 is b. So now we can plug that in. And that should do it. That should be the model that we want. But now we have to find out how long it'll take to reach 103,200 cases. Put that 103,200 here on the left. And then you'll have everything except the time t. And you just have to solve it for t. Okay, so now what I'll do is I'll multiply the denominator to the other side. Okay, we'll divide. Subtract 1. Okay, now we have to isolate the E. And at that point, e to a ln of something would cancel out, but e to a negative ln, I wouldn't make that assumption, so I'll just take a ln of both sides. Now these two definitely do cancel out, but you'll have this. Okay, now we can get rid of the negatives. And then we'll just divide. .07, and that would be in weeks.